G'day there. Today we're going to be having a look at some drill motors used as generators. And I've gone a bit crazy and pulled apart a bunch of drills that have all stuffed batteries. And the first one I'm going to be looking at is this one that has a 2-speed gearbox. Okay, so, and I've just got some alligator leads hooked straight onto the motor terminals on the back of the drill, and they're going over to this pair of LEDs that are together in anti-parallel, so that it doesn't matter which way I turn, one of them's going to light up. Just makes things simpler to work out. You can see this is in, now when this was in a drill, the motor always turns faster than the drill head. So you have step down gears, or reduction gears. This has two different levels of it. It's got a mildly step down for a high drill speed, which would be considered second gear, and a first gear which has got a big step down for a very slowly turning drill head and lots of torque. So this is in the higher, in gear 2, what would be the higher speed drill, and this is obvious because it's easier to turn. I can turn that quite hard. I'm using a fishing rod handle off a fishing reel, and I turn that really fast, and I can't get any light out of my little LEDs over there. But when we click over into second gear, it's a lot harder to turn, and with a bit of turning I can get one to light up, and the other way I can get the other to light up. That's not really ideal, because I'm putting a bit of force into that and turning fairly fast, and I'm going to get tired pretty quick. And if I was looking at harnessing some sort of energy from my environment, a wind turbine or a water wheel or something like that, or a gravity weight, I need to put a lot of energy in that for not much out. And we'll just have a quick look at the specs on the multimeter. I'll set this one to volts. Probes in the right spots. Try them together. I'll get some backlight for you. My backlight wants to turn on. Been playing up lately. I think this multimeter's a bit sick. There we go. Alright, so this is DC volts displayed on that meter, and I'll make sure it's in gear. Right, when I'm turning that flat out, I'm seeing a bit over 4 volts. It's really fast, I'm getting up to 6. Okay, so between, that's like 1.5 to 2 volts. Near 3, getting up to the 3 volts LED range, and 6 volts is the most I can get out of it. Now that was a 12 volt, no, what was that? That drill was, it doesn't say, I think it was a 9 volt drill maybe, going off those NiCads there. That'd probably be, well, it might be a 6 volt drill. 4 NiCads in series, I'd say. Alright, so let's move on to the next one, and I'll show you in one that hasn't been pulled apart. So here we have a 12 volt drill, and I've just taken the battery pack out, and I'm going to put these clip leads on the terminals inside where the battery pack would have connected. We'll ditch the multimeter for now, and come back to that later. If those of you are wondering about current, you can get over an amp out of some of these motors, but you do have to turn them pretty hard and fast. There's a pair of LEDs. And the handle. It's hard to turn, and it's not doing anything because I wasn't holding the trigger down. Now that's pretty decent off the old 12 volt drill. And that's a loose connection somewhere. And I can also change directions with the direction knob chooser on the drill. Yep, and there, you can see that LED no longer works, and that LED no longer works. So you can get some pretty significant current there. Throw them in the rubbish bucket. Now, where things get really interesting is when you move on to a cordless drill, gearbox, much like the others. But this one has a variable speed trigger. Those other drills we looked at both had simple on-off triggers, no variable speed. Just on-off and direction control. And there's the motor from the other drill. The trigger, sorry. From the black one, all pulled apart. I actually pulled the trigger switch completely to bits, and it is just an on-off switch. There's no variability to it at all. In this one, we have this MOSFET here. You can see that, and it's got a ferrite choke on there to suppress induction. And that they've put that choke tells me that this MOSFET doesn't like back spikes in voltage. I have looked up the data sheet, and it does actually have a bunch of Zener diodes inside. It's got a Zener diode across the gate and source, the drain and source, sorry. And it's also got back-to-back Zener diodes from the gate to the source and to the drain. So it shouldn't really be able to hurt it. It should just short out through the Zener diodes if too much voltage spike is applied. But they're protecting it anyway. And because of that, you don't want any back... And there's other electronics on this one too. There's this little screen that lights up and tells you how charged the drill is and what percentage it is. It's got a little digital display on there and the LED work light that shines out just above your trigger. And to protect all that stuff, they don't want people to turn the drill and generate power. I can't turn that. It's just jammed. So we're going to pull it apart, and I'm going to show you how to disassemble this gearbox and reassemble this gearbox so that it can be used as a generator. And bear in mind that if you do this and put it back in your drill, you could damage your variable speed trigger. So if we look around, we can see these 3 screws. 2, 3. We're going to undo them. And careful not to lose any of our screws and stuff, and that's what this tub's for. Because in a minute stuff could fall out. And I've already disassembled and reassembled this one a few times, so I know what's going on in here. But I can assure you the first time it all fell out on me, it took quite a while to work out, and I was very lucky to find all my pieces. So make sure you keep the 2 halves together till you've got these screws loosened off properly, enough that you can pull it apart. And if we carefully lift this out this way, we can see the drive shaft off the motor with its cog. Lots of grease, which is a good thing. And it's got this planetary gearbox inside. So I'm going to take the planetary gearbox out, and these things, these little cogs, they all come out too. So you do need to be very careful. If you turn this upside down, stuff goes everywhere. You've been warned. And I was lucky that time. Whoop, I didn't drop any of my gears. There's another lot on the other side. Okay. Very tricky little gearbox, but it is a good solid rugged gearbox. It's near indestructible. Now the bit that'll really throw you is if you look down there, you can see those 8 ball bearings. And they're just loose. And what they are is they are for the slipper clutch part for when you don't want your screw, for when you want it to go click, click, click as you're doing up a screw into the wall. So you don't want it to do the screwing too tight. You use the torque settings. And at the moment I have it set all the way around on just plain drilling. It's locked in. And those little ball bearings interact with these little teeth here. And when you turn your torque setting adjuster, and there we go, like so. You probably can't see in this video, but it does actually raise the little ball bearings up and down. There's little platforms underneath, and they will raise up and down. When they're at their highest position, they're going to stop this from being able to bounce up and down over the top. When they're in their lowest position, this can slip over and it disengages the drive. Lets the drill keep spinning, but the motor spins, but the drill head does not spin, and it just goes click, 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 click. Alright, so I'm going to very carefully try and leave those in there for the moment. It's a lot easier if you do. And I'm going to look at this part that comes out here next. This is the drive for the planetary gearbox. And we can see on the other side there are some teeth, and they're different sizes, and that's very important, and the way they go in is very important. So just note that when you take it apart. And for me, that means that the bigger gap goes on the bigger pieces of metal that you can see in there. And you'll also notice those two little round bits, and one of them's not quite centered. Now they're called needle roller bearings. I'm actually going to... Oh, and I'm back, sorry about that, my flattery went back. So, if we have a look inside the little gearbox here, I've got these teeth on this part here. Different spacings, a large spacing and a small spacing. And in here we can see that there's some lugs in there that it meshes in with. So that goes like that down in there, inside. And we can see that there's two fixed lugs that are big square looking ones, and two little round lugs. If we look really closely, we can see the round ones are actually just free floating needle rollers, and there's flattened off faces in there. And that's me turning the end of the drill, and that's jammed. I can't turn it any further. It gets stuck on the needle rollers. You can see what's going on there. But yet when this is in the right way, which would be that way, I can turn that, and it turns the drill head okay. And I'll try and turn the drill head, nothing happens. It jams. So what we're going to do, we're going to get our little pony pliers. We're just going to remove those needle rollers and throw them in our container. I ended up not needing this time because I managed to not drop all those ball bearings out. But as I think I warned you before, they do just come out. And the pliers are magnetic there, which is how I was able to pick that up. But the first time I opened this drill apart, I just tipped upside down, tapped it on the bench, and the little cogs all came out of there, all 6 of them, and the ball bearings went everywhere, and I was very lucky to find all the pieces and be able to work out how to get it back together again. It's not that complex, but it's tricky enough to give you problems. So now back to the reassembly. We've got the needle rollers out, and we'll drop that one back down in there. And we can turn it and get the head to turn. And now we can get that to turn the other way too. So now what we've got to do is get our gearbox back in. Now you'll notice there's 3 pins on that plate that I just put back in the drill head. Transfer plate. And there's 3 holes in those gears, so you need to line them up carefully. Whoops, and I've just lost a cog out of the back. Nearly. Very fiddly stuff here. The ones in the back do have their own little pins that they sit on. The ones in the front side use those pins to sit on. But it has to be assembled this way. I don't think... Oh, yep, there we go. And that's the action you want to see. The outside not turning and the inside's turning to make sure that you know you lined up on those pins. It is possible to slip that all together and have the teeth, the pins that are supposed to go in the middle of the cogs, go in between the cogs. And you put it all together and it won't work. So there you go, you can see that planetary gearbox in operation there. So now we put on the motor back on, which has got the final stage of the reduction gearing. And there is a way that goes. There's a little lug sticking up there on the edge, and there is a corresponding hole on the other side that joins into. And if it doesn't want to quite squeeze together, you should just be able to turn the handle a bit and jiggle things around, and it should hopefully slip together without giving you too much trouble. And do it all up again. And don't be tempted to turn it heaps like I just did with the screws undone, because it's a great way to drop stuff and have all the little cogs and ball bearings go everywhere. And I did do that in learning how to do this. And now we have a perfectly good generator. It's a bit sticky in one direction for some reason. I think I might need to open that up and reapply a bit of extra grease in there. I really should have greased it up more, but I'm trying to keep this video short. It's gotten a bit sticky in one direction. Let's check this with the LEDs, and hopefully these are the ones that I didn't just blow up a minute ago. And that's not too bad a turn rate for the brightness. And this was an 18 volt drill, so the higher voltage drills do work a bit better. That way's a bit stiff. I'm going to have to recheck that gearbox and work out what I've done there. And those little ball bearings are actually for this torque adjuster. So that's not actually turning the motor. You want to make sure it's turned all the way around hard onto the drilly part. And that works quite well. Now let's have another look at the voltage and current from some of these drills. We looked at the voltage a moment ago. Now let's look at the current. This is hard to do with one hand, as I'm sure some of you guys that have done your own videos know. Okay, and a light on. This is on the 10 amps range. There is a little decimal place just there. So we've got all 3 digits of milliamps and 2 digits of amps. And we can see, even just for some gentle turning, and this has gotten really hard to turn now because it's shorted out. There's a 2.2 ohm resistor in this multimeter, which is how it measures the amps. It's just a dead short, and it might as well have a 2.2 ohm resistor straight across there. So there's over an amp. And if I really reef that, that was 2 amps. Two and a half amps. 3 amps. Okay, and if we switch it back over, oh, I think we're going flat. Might need a new battery in my meter soon. Switch it back over to volts. And it's gone flat. We'll switch over to the other meter again. It's alright, I'll have to take those batteries out and charge them up. I always use rechargeable batteries in my meter because otherwise you hang through heaps of batteries. We'll go to voltage. And now that's gotten easy to turn again. And so, yeah, 6 volts is about our max from turning really fast. 8 volts there. This is certainly a lot easier to generate the voltage on though, and the current, than the 12 volt motor or the 9 volt motor or the 6 volt motor or whatever the other one was. So if you're looking for a drill to use to cannibalise for some sort of wind or water or gravity related project, then you would look for one that's got as high a voltage of battery pack as possible, even if the battery pack's stuffed. You want an 18 volt really, or a 12. And you want one that, if it does work and you can check, that spins as slowly as possible on the drill head for a good charge in the battery, meaning that you've got a very high ratio gearbox. Because you do need these DC motors when you're using them as generators. They're pretty crappy generators. They're nowhere near as good as what a generator would be. There's the specs on this one for anyone that's interested. Yeah, these DC motors don't make the best generators. They do generate quite a bit of current. The voltage will be a lot lower than the drive current required to run them as a motor. So, and you need to spin them fast, very fast to achieve that. And so you want the best ratio gearbox you can get. Okay, I think that's about it. I think I've covered everything. One thing I did do, I didn't show you this. I'm not sure if I showed you this drill out of a 12 volt drill. I'll chuck the handling in quickly. I'll give you an LED display. What I've done here is I've pulled part of the trigger apart, as I explained before, to make sure that it was just an on-off switch and not a variable speed trigger. And that drill that had all the bits that I pulled out, the roller bearings and stuff that I pulled out, that was all purely to protect the variable speed. And sorry, I'm dropping stuff all over the place here. Tighten that up. And that'll be the burned out LEDs. But what I did leave on with this one, the other part of the trigger was just in between these two black wires here that I've soldered together. Just taking the switch out of the circuit. The other thing that I have left on though is a direction changer. So, me turning in one direction, lights up that one, lights up the top LED. I'll see if I can spread them apart so you can see better. Alright, and when I flick this switch over the other way, it now does the opposite to the direction of wind. I'll flip the switch, I'll wind in the same direction again, and it lights up the other LED. Okay, probably a bit hard to see that here. Try holding it like this, how's that? That's the reasoning for having those anti-parallel LEDs for testing stuff like this, where you don't know which way the polarity is going to go. It can tell you which way the polarity is going to go. And if you're putting out AC, like from a stepper motor, it will light up both of them. So that's a handy little trick. So there you go. I think you now know more than what you ever wanted to know about cannibalising cordless drills to be used as generators for DC power. Thanks for watching.